We'll get started here. We're talking about Boeing Starliner. They've had their problems over the years, everything from corroded valves to software glitches that led to clock errors so that they shut off the engines prematurely, to having flammable tape. They've had a whole series of problems. Actually, they had their act together. They were ready, and it turned out they had other problems this time. We're getting pretty close to actually having a Boeing Starliner, we think. Well, first of all, what is it? It is designed to carry crew to the International Space Station. That's its purpose. This particular test that we actually should have just had, but they had to postpone, would have sent 2 astronauts up. They normally would take a total of 4, but this is the first flight, so they're just having 2. It was scheduled for May 6th, then it got postponed. Now the earliest launch will be May 17th, so it may still be pretty close. There was a valve problem, and it was on the Centaur rocket on the upper stage. It was not on the Boeing craft itself. It's not directly Boeing. Now, of course, ultimately, Boeing and Lockheed is a joint venture, which is United Launch Alliance, that builds these rockets. So Boeing's still involved, but at least it wasn't directly Boeing. So the history. The idea was actually they could transport up to 7 people. The NASA plan is 4 people plus cargo. I mean, the same is actually true for the SpaceX equivalent here. It actually started in 2010. People think about 2014 when NASA put out a big contract, but the work really started in 2010. They put up some of their own money, and NASA put up $570 million. So it was developed partially with their own funds, but 2014 was the big funding for this thing that got it going. It's called the Commercial Crew Program, where NASA was essentially buying a service. This is part of the shift that NASA has been making from buying stuff and running it to buying services, in this case, a transportation system to deliver the astronauts. They did this under a fixed price, and actually they've lost about $1.5 billion because of the fact they're so late. There's a minimum of 2 that they're committed to with options on another 4 deliveries of astronauts to the station. So they're way behind. The competition here, of course, is SpaceX with the Crew Dragon. They also had done some work prior to the 2014 grants. They were only given $2.6 billion, so they got less money, but they finished it 4 years earlier at least. They actually put a crew up in 2020. They've had maybe 13 launches or something like that, and taken quite a few up to the space station, plus 1 even not related to the space station.
The question came up on the reusability of the Starliner and the Crew Dragon.
They claim 10, and SpaceX is 15. They both claim reusability quite a bit. There is, in reality, somewhat of a difference in that in the architecture of the Starliner, there's a lot of stuff in what's called the service module. And they call it a trunk in the case of SpaceX because it's pretty much just a cylinder of aluminum. It does have some radiators and it does have solar cells for providing power, but it doesn't have engines. The engines are all up in the main capsule. Whereas here, there's a lot of engines back in the back, and there's apparently a lot more stuff. And the service modules in either case are thrown away. I mean, they're just burned up in the atmosphere. Now, the turnaround time is said to be about 6 months, so it's not like you can just refly the thing immediately. But they don't really need to because they were only contracted for 1 launch a year, so that fit the original design specification. So it's kind of been SpaceX versus Boeing, and so far SpaceX has been winning. But they were hoping to start to address that with this launch. So a little bit about the designs. The very top part of that is the crew capsule, and that is the reusable part. I made a note, it's kind of a minor thing, but there's no fairing. Normally, if you're launching cargo, you protect it with a nose cone kind of a thing. Those pop off after launch. You can't do that when humans are involved because if there's some kind of a problem during the launch, they have to be able to fire rockets immediately to get the thing away. You'll notice the SpaceX version does that too. Okay, the next section down is that service module that I was talking about. And you can sort of see there's a break and there's something just below that. That's basically just a skirt, and that's really just for aerodynamics, that you get so much turbulence there that they want to actually direct that down so more of it actually hits the first stage rather than the second stage. And that's just is an aerodynamic thing. Now, that top stage then, the Centaur 3, that's different than what's coming up on the Vulcan Centaur now, which is Centaur 5. It's somewhat different. The one thing that's kind of weird about this is a dual engine one. They have never done a dual engine one since 2004. They say that they want 2 engines because they want more power. They want a flatter trajectory during the launch so that there's not such high G-forces on the astronauts. The highlighting is that it is very different. In fact, this is the first time an RL-10 engine, which is the engine in this thing, has actually carried any human to space. So it's kind of interesting. But anyway, this whole thing is the forerunner of the Centaur 5 that's in the new Vulcan rocket from ULA. And those do have 2 engines. Anyway, lower stage, Atlas V. Both of them use liquid hydrogen and liquid oxygen as propellant. Now, they could use something other than the Atlas V, But other than the Falcon 9, they're all ULA rockets that have been discontinued. Like the Delta IV Heavy, they could use that, but there are no more of those. There's still some Atlas Vs that are coming, but they're based on the Russian engine, and there's a finite supply of those. And when those run out, that's the end of Atlas. Another interesting part about the Starliner design is it lands on the ground, airbags, pretty much like fancier versions of what you have in your car. And there's a picture. This was one of the earlier tests, 2019. They dropped it down White Sands, New Mexico, and those are presumably the parachutes. They're kind of off to the left. But anyway, they land with airbags. And they could do a sea landing with that as well. But they were trying to avoid all the extra commotion associated with sea landings. So what went wrong? Basically, a pressure release valve failed on the upper stage rocket. You've all got them in your house. If you have a water heater, hot water, you're heating up hot water, you have a pressure relief valve to keep the thing from blowing up. It's a safety device, basically. I got the picture of one of these valves over there. Imagine your hot water tank or your rocket is underneath you there. If the pressure gets high enough, it just basically pushes up that assembly that's held down by a spring, and then it goes shooting out. It's pretty much as simple as that. So when the pressure is high, it opens up, a bunch of material flows out, and as a result, the pressure drops and it closes. Now, what's happened here, though, is they're getting what's called chattering, where it's opening and closing very, very rapidly. They're not supposed to work that way. That's not the normal design. Sometimes that indicates a design problem. I mean, you can imagine if the thing were really made way too big, what will happen is the second you open it a little bit, a huge amount of material leaves, and then it would slam shut, and then it would build back up, and you'd open and let out a huge amount. So that's one way. And you have some different sort of problems that happen if the valve is too small. We don't actually know what the arrangement of this thing is inside the rocket. I mean, for instance, if there's a pipe leading to it, actually that could be a problem because you get too much pressure drop. You try to force a lot of material through a pipe that's too narrow. It's just like sizing the thing too small. And what will happen is the pressure decreases so much that then the thing slams shut because of that. Basically, there could be a design problem. You wouldn't think that'd be it because this is pretty mature technology unless they changed something on the Centaur with the two engines. So it was not completely clear why. This thing was jetting really fast. I mean, they were talking about like 40 cycles a second, 40 hertz. They heard it. The reason they knew they had it wasn't from instrumentation. They saw that later when they started looking at some detailed data. But basically, the ground crew heard it. Why did they have these kind of problems? It could be a design problem, but probably not because they've done this before. It's probably just a defect. It is funny, though, because certainly Boeing has had their problem with valves over the years. It's like whoever they buy valves from, they ought to buy them from different people. It's a tough service, though. I mean, we're talking about liquid oxygen. It's cold. So metal's brittle, and that's actually a problem with something like this. If you get shattering, the thing's banging away 40 times a second. That's not really good for most metal when it's brittle and it's, 100 and whatever degrees below zero. Their particular limit on this valve was 200,000 cycles. And you think, well, wow, that sounds like a really big number. But if you think about that, if it's really opening and closing 40 times a second, that's only a couple hours. It doesn't really take that long to hit it. Now, what they said was, if it doesn't open all the way, it's not quite as bad. It's the worst case if it opens all the way and then slams back. If it's just a little bit, maybe not. One way or another, they've got to figure out why they're doing that. They apparently have had this problem before, at least twice. And once very, very similar, maybe 10 years ago, was on a cargo. And what they said was, if you have humans, you're not really allowed to change the state of the system because it's just too risky. The problem is they have a solenoid, which is an electrical plunger, essentially. They can force it open or force it closed. And on the cargo versions, they just forced it open, forced it closed, and everything kind of settled down and they went on their way. You don't want to do that when you have people. The problem is, imagine if you force it closed, well, what if the pressure really is building fast? The whole thing blows up. And you care a lot more if there's people there. On the other hand, if it's open, you're putting out a lot of stuff in the atmosphere. In this case, it's only oxygen, but still, you might get an explosive mixture. You're much more likely to be near the rocket. So they say, well, if you have people involved, we don't do that. So these people are saying, gosh, if only it were just cargo, we would have just ignored it and gone ahead. But they couldn't do that. At least that was their own official policy.
Also, if too much oxygen leaked out, it might not even be possible to reach orbit.
All those things anyway, saying you might take risks if it's only cargo, but you're not going to do that with people. So anyway, they're going to have to replace it. Now to do that, they got to go back to their vehicle integration building, their hangar. And they said they don't have to unstack the thing, but they have to be able to support it while they're taking it apart so it doesn't collapse. Once you've gone to all the trouble of taking it back, you are going to replace it. I mean, then they can look at the valve, and yeah, afterwards you can tell. They don't have direct data on this. What they do have is the accelerometers in nearby places, like the engines, actually could pick it up. So they have some data on that, but they actually had that the same day. So that's the story on that. That's what went wrong.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of the National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.